Integrator circuits and operational amplifiers. Introduction. The ever increasing demand for reliable electronic equipment of smaller size and the low power requirement in communication, computers, and aerospace industries has led to the growth of micro miniaturized circuits. One type of such circuits, called an integrator circuit, abbreviated as IC, is a combination of components like diodes, transistors, resistors, capacitors, and their interconnections grown into one or more complete circuits. The idea of electrically isolating the devices from each other on a semiconductor wafer instead of mechanically cutting them apart led to the formation of ICs. Jack Kilby invented the IC in 1958 and was awarded the Nobel Prize in Physics in 2000 for it. Jack Kilby invented the IC in 1958 and was awarded the Nobel Prize in Physics in 2000 for it. From the fabrication standpoint, integrator circuits can be broadly divided into two classes, monolithic and hybrid. In the monolithic IC, all the circuit components and their interconnections are formed on a single piece of crystalline silicon. The term monolithic is coined from two Greek words, monos meaning single and lithos meaning stone. Silicon ICs are fabricated on circular, extremely flat, defect-free, lightly doped silicon sheets termed wafers. Usually, the wafers have a thickness less than 1 millimeter and diameters in the range 100 to 300 millimeter. A wafer consists of a large number of identical areas. Each small area contains an integrated circuit and is called a chip. The number of chips accommodated in a wafer depends on the size of the chip and of the wafer. A chip is square-shaped and has an area usually less than 1 centimeter square. A large number of circuit components can be accommodated in a small chip. For instance, about 35 transistors, 30 resistors, several capacitors, and their interconnection can be contained in an IC chip of area 1.65 mm into 1.65 mm. A hybrid IC can be formed from a number of monolithic ICs. In the hybrid structure, the components are mounted on a ceramic substrate and interconnected by wires or a metallization pattern. According to their mode of operation, the integrated circuits are classified as linear and digital. In linear ICs, the input-output relationship is linear. Linear ICs find applications in amplifiers, oscillators, modulators, voltage regulators, etc. The digital ICs frequently involve some form of bistable action and work as switches. They are either on or off and not operated in between. The application of digital ICs include computers and logic circuits. Since the first appearance of ICs, the number of components per IC is doubling every 1 to 2 years due to the advancement of technology. In 1998, memory chips with about 269 million transistors were available. In 1998, memory chips with about 269 million transistors were available. This trend of doubling was predicted by Gordon Murray, co-founder of Intel Corporation, and is hence known as Murray's Law. The advantages offered by an IC over a discrete circuit design are as follows. ICs allow batch fabrication, that is, hundreds of identical circuits can be formed simultaneously on a single silicon wafer. The circuits thus become inexpensive. Since ICs are very small, they are less likely to be faulty due to defects in the silicon wafer or in the fabrication steps only. Also, failures due to the soldered interconnections of discrete components are absent. As a result, the reliability of ICs is much better. As ICs are much smaller in size and weight, they are useful in applications where weight and space are critical, such as in aircraft and space vehicles. Maintenance becomes easy with ICs since the entire circuit can be replaced quickly and easily. Miniaturization and cost reduction of ICs allow much more sophisticated electronics than through discrete components. Large-scale integration (LSI) gives considerable reduction in system size, thus increasing the speed of the signal transfer time between circuits. Due to the miniaturization of components and connecting leads, the high frequency performance of